Hello, in this video, I will explain to you on how to solve this problem. In problem 17 through 19, using Kirchhoff law, see example 2 and showing the details, find the currents in this circuit here. Okay, let's draw the details in the circuit here and also label all the necessary things that we need to do in the analysis. Okay. So here we have I1 here, and that will pass through this battery and also this 4 ohm resistor. So the current that passed through this 4 ohm resistor is also I1, like this. And then I2 comes down here, and it is in series with this current here. So this current here is also I2. Good. And here I will have I3, right? Because this is I3 in this branch. So we'll have I3 here. Good. And now we need to also label the polarity in the battery and the resistors. Okay, for the battery, it is easy. The long one here is the positive side, and the short one is the negative terminal. And here we also have the long one is the positive side, and the short one is negative terminal. For the resistor, where the current comes from is positive side, and where the current goes to is the negative side. Good. And here where the current comes from is the positive one, positive terminal, and where the current goes to is the negative terminal. And this also the same, so this one will be positive and this one will be negative. It will be very useful for the loops. And talking about the loops, let's make the loops here. So I will use this loop here because this is going up and then down. I think I will use this loop here as loop 1, clockwise like this. So we have loop 1. And here that is also clockwise like this. I think I just use this loop here, which is also clockwise. So we will have loop number 2. Okay. And all we need to do is to use the Kirchhoff laws to get some equations here. Let's use this point here as point A. And I think we can use the Kirchhoff current law or KCL at node A. And what does KCL say? KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. What is the current that goes into point A here? I will have I1. So we will have I1 here. And that I1 is equal to I2 plus I3, right? So I have I2 plus I3. Good. Okay, now what can we do from here? I think we have to do KVL here, the Kirchhoff voltage law, but at loop 1. KVL at loop 1. KVL said that the sum of the voltage in a loop will equal to 0. However, we have to be very careful about the sign of the loop here, the sign of the voltage. Okay. Now let's start here. Let's start from this battery here. The loop entering from the negative terminal. So we'll have negative sign. And then we will have 12 volt, right? So I'll have minus 12. And then let's move on to this resistor here. So we will have this current entering this positive terminal. So I will have plus. And we will have 4. But to get the voltage, we need to multiply resistance by the current. So I'll have 4 I1 here. And then we move on to this 12 ohm resistor. And here, the loop entering from the positive terminal, right? So I have positive sign here. And so we will have 12 multiplied by I2 to get the voltage. Good. And the last component in this loop is this battery here. And the loop is entering from the negative terminal. So I'll have minus sign here. And we will have 24. Okay. All of that will equal to 0. Good. Okay, now we can take care of this I1 because I1 is I2 plus I3. So I have 4 I2 plus I3 and then plus 12 I2. And I will have minus 12 minus 24 is minus 36, and move it to the right hand side, I will have 36. And so we will have 4I2 plus 12I2, that will be 16I2. And then we will have plus 4I3, and that will equal to 36, right? And so we can divide both sides by 4. So we will have 4I2 plus I3 is equal to 9, right? Good. Now let's do another KVL, but this time at loop 2. Let's do KVL at loop 2. And again, we play the same game here. The sum of the voltage in a loop will equal to 0. Okay, maybe let's use different highlighter here. Let's start from this 24 voltage source. So we will have the loop here entering from the positive terminal. So I have positive sign and the voltage is 24. Good. And now let's move on to this resistor here, and now the loop entering from the negative terminal. So we will have minus sign here, and the value is 12, and the current that pass through it is I2. So I have 12 I2. Good. And now let's move on to this I3 here, and the loop entering from the positive terminal. So we'll have plus, and we will have 8 multiplied by I3. Okay, all of that will equal to 0. And we can rearrange this into simpler equation, which is 12I2 minus 8I3. That will equal to 24. Okay, we can divide both sides by 4, I think. And I think we will have 3I2. And then minus 2I3. And then that will equal to 6. Good. And let's save this as equation number 1 and this as equation number 2. Okay, we need to solve this equation. Solve equation number 1 and solve equation number 2. Okay, let's exactly do that, right? So let's solve 1 and 2. I think I just use elimination here because they are easy to do, right? So I have 4I2 plus I3 is equal to 9. Okay, and then we'll have 3I2 minus 2I3 is equal to 6. We can just multiply this by 2 and this by 1 here to eliminate this I3, right? So we'll have 8I2 plus 2I3, and that will equal to 18 here. And here we will have 3I2 minus 2I3, and that will equal to 6. And we can just add them up. Right, so I think we will have 11I2. 11I2 is equal to 24. So I2 here is equal to 24 over 11. Okay, so I have 24 over 11, and the unit here is ampere. So that is the value of I2. If I did not make any mistakes. Okay, and for I3 we can just substitute this I2 into one of them, right? So maybe let's substitute that into equation number 1. Okay, maybe let's plug this I2 here into this equation here. So I will have I3 there is equal to 9 minus 4I2. Okay, and then we will have 9 minus 4 multiplied by 24 over 11. Okay, that is not a great number here. So 9 is 99 over 11. And then minus, we will have 96 over 11. And so we will have I3 here is equal to 3 over 11 ampere. And that is for I3. But from there, we can calculate I1, right? So we will have this one here. So I1 is just I2 plus I3. So 24 over 11 plus 3 over 11. Therefore, I1 is 27 over 11. And the unit here is in ampere. And I think we get all the answer here, right? So I1 is 27 over 11. I2 is 24 over 11. And I3 is 3 over 11. Okay, hopefully I did not make any mistakes during my calculation, because this is very prone to error and a long calculation. But yeah, let me know if I did make any mistakes during the calculation. Okay, and as usual, thank you for watching. If you get any questions, send me your problem here, rdisatria11@gmail.com. Okay, thank you for watching. See you in the next video. Bye-bye.